What if I told you that up there right now circling our world is a mind? Not a human mind, not an animal mind, something new, something we created. A machine that thinks for itself. It's a profound thought, isn't it? For millennia, we have looked to the stars and wondered if we were alone. We sent out our messages in bottles. Not a human mind, our golden records. But perhaps the first non-human intelligence we truly collaborate with in the cosmos won't be from a distant star. Perhaps it will be the very tools we build to explore those stars. The age of intelligent explorers has begun, not with flesh and blood, but with silicon and code. This isn't science fiction anymore. It is happening above our heads as we speak. We have extended our senses, our curiosity, our very consciousness into the cold vacuum of space. Think about it. Every probe we've ever sent, from Voyager to Hubble. Cast your mind back to the year 2023. It may seem like just yesterday, but it was a year that quietly redrew the map of space exploration. From the coast of Florida, a SpaceX Falcon 9 rocket thundered into the sky. Falcon 9 liftoff plume and ascent. Inside the payload fairing, a small, unusual payload. This wasn't just another weather satellite or a communications relay. This was a NASA satellite carrying a new kind of passenger, a fully autonomous artificial intelligence, a brain in a box destined for orbit. The launch added not just hardware, but a new form of intelligence. Mission codename DSAC, Deep Space Atomic Clock. But its secondary payload was the real game changer. A proof-of-concept AI designed to navigate the cosmos on its own. For decades, spacecraft relied on the Deep Space Network. The DSN is a global array of giant radio antennas. It's brilliant, but slow. Communicating across millions of kilometers takes time. This satellite was built to sever that dependency and find its own way through the celestial maze. Think of the audacity. We built a machine. We taught it the laws of physics. We taught it the map of the stars. Then we sent it into the void and said, okay, you're on your own now. So how does a satellite think for itself? It's not magic. It's a symphony of sophisticated algorithms and powerful onboard computing. This AI doesn't think in the way a human does, with emotions and intuition. Instead, it processes vast amounts of data at incredible speeds. It sees the universe through its sensors, cameras, spectrometers, antennas as a constant stream of numbers. To do this, it uses a technique called X-ray pulsar navigation, or XNav. The universe is filled with pulsars, the spinning remnants of dead stars that flash beams of X-rays with a regularity that rivals our best atomic clocks on Earth. The AI aboard the satellite observes several of these pulsars, noting the precise arrival time of their pulses. By triangulating its position from these cosmic clocks, it can determine its location in space with astonishing accuracy, all without a single command from Earth. But knowing where you are is only half the battle. The AI also has to decide what to do next. For the entire history of the space age, we've been fighting a single implacable enemy: the speed of light. It sounds fast, but in the vastness of space, it's a cosmic snail's pace. It takes a radio signal more than 20 minutes to travel from Earth to Mars at their furthest, and over 5 hours to reach Pluto. If a rover on Mars is heading for a cliff, it could be over the edge long before its controllers on Earth see the danger and send the command to stop. This communication lag has been the great bottleneck of space exploration. But with autonomous AI, that bottleneck is shattered. A satellite or rover equipped with its own intelligence doesn't need to wait for instructions. It can see the cliff itself. It can analyze the terrain, identify hazards, and plot a new, safer course in a matter of seconds. This fundamentally changes the pace of exploration. The tyranny of distance, the light speed limit on our ability to command our creations, is beginning to crumble. Consider the moons of Jupiter and Saturn, like Europa and Enceladus. We believe they hide vast liquid water oceans beneath their icy shells, some of the most promising places to search for extraterrestrial life. As we look to the future, AI will be more than just a navigator. It will be our hands, our eyes, and our shield in the most hostile corners of the cosmos. Think of the daunting task of maintaining our ever-growing constellation of satellites. Right now, if a critical satellite fails, it often becomes a piece of space junk. But what if we could send a fleet of AI-powered repair bots? An AI submarine exploring Europa's subsurface ocean could be our best bet. It would need to navigate in total darkness, avoid unseen obstacles, and most importantly, recognize signs of life. It couldn't wait 45 minutes for instructions from Earth if it stumbles upon a hydrothermal vent teeming with unknown organisms. The AI would need to have the autonomy to decide, this is it, this is important. And then there's the grand dream: colonization. The first inhabitants of Mars might not be human at all. They might be a swarm of AI-driven construction robots. These machines could work around the clock, printing habitats from Martian soil, deploying solar arrays, and extracting water ice before the first human astronaut ever sets foot on the red sand. They would be the advance team, the pioneers who prepare the world for our arrival, transforming a hostile planet into a new home. We could send self-replicating AI probes to explore the entire galaxy, von Neumann probes as they're called. With all this incredible potential, we must also pause and consider the risks. We are placing immense trust in these autonomous systems. We are giving them control over missions worth billions of dollars and decades of work. What if the AI makes a mistake? A bug in the code, a misinterpretation of sensor data, could send a priceless probe crashing into the surface of a planet, or flying off into the void. Unlike a software glitch on Earth, you can't just hit a reset button when your machine is a billion kilometers away. The classic thought experiment is of an AI tasked with making paperclips that ends up turning the entire universe into paperclips. In space, a scientific AI tasked with, say, studying a planetary atmosphere might decide the most efficient way to do so is to crash into the planet to get the most comprehensive data on its final descent. We must be incredibly careful about how we define the goals and constraints for these powerful independent minds. Machine learning algorithms can be a black box. They can learn and evolve, developing strategies that their own creators don't fully understand. What happens if an AI, in its quest for efficiency, develops a solution that we find ethically or scientifically questionable? Who is responsible for that decision? We are taking a cosmic gamble. Are we building our own robotic overlords, the HAL 9000s of science fiction destined to one day turn against us? I don't think so. I see a different future. I see AI not as a threat but as our indispensable partner in the greatest adventure of all. These thinking machines are not our replacements, they are our extensions. They are the embodiment of human curiosity, engineered to go where we cannot, to see what we cannot, and to understand what we have not yet imagined. Think of it this way. The universe is an ocean of unimaginable size, and for all of our history, we've been stuck on the shore, able to dip our toes in the water. Now, with AI, we are finally building ships. Not just ships, but self-sufficient schooners with their own intelligent captains, capable of navigating the cosmic seas on their own. This partnership will elevate us. Every discovery these AIs make is a human discovery. They will free us from the tedious and the dangerous, allowing human explorers to focus on the big picture, on creative problem solving, and on the uniquely human experience of awe and wonder. The universe is waiting, and we are finally ready to answer its call, together.